All right, guys. Today we are going to do lesson 3.5, but a second day of it, which is just on piecewise equations. And today we're actually just going to be looking at breaking down absolute value functions and then rewriting them as piecewise. Because if you can kind of see it, absolute value is almost like two lines that meet in one spot. So what I want you guys to do as a warm up is just find the zeros, and then number 2 right here. I'm going to actually change it so that it is, I'll add something to it. So why don't we do, f of x is equal to, um, we'll go 3x minus 4, and that's only going to be from negative infinity to 0. And then why don't we do something like x squared minus 1, and that's going to be from 0 inclusive to infinity. And then g of x will be a piecewise function, which will just, why don't we just say 4, from negative infinity, let's go negative 1 inclusive, and then we'll say negative x minus 3 from, we'll go negative 1 not inclusive to infinity. All right, so those are your two warm-ups, and then, at the bottom you're going to find f of g of, we'll do 1/2. Okay, so do those two, pause the video, and then resume it when you're good. All right, number 1, we're looking for zeros of 2x plus 1 minus 7. So what we can do, we'd set f of x equals to 0. We would add 7. So we get 7 equals the absolute value of 2x plus 1. Okay. And what we've done in the past is basically the absolute value means this thing you could drop the bars and just solve it for like that case 1. So you could say 2x plus 1 equals 7. You can subtract 1 and then divide by 2, and you get x equals 3. And that's the first one. But remember, the second one is if you made the whole thing negative. So you could either make 7 negative and then drop the bars, or you could make 2x plus 1 negative and drop the bars, because it doesn't matter. They're the same thing. If you make one entire side negative, then the absolute value is true. So I think you guys are used to just making negative 7, making this negative and then solving for it. I'm just going to show you, we could also make the entire other thing negative. So we could say, negative 2x plus 1 equals 7. And it's the same thing as making this negative 7. It's just the negative would be transplanted over here. But basically, if what's inside the bars is negative 2x plus 1, then once you take the absolute value of it, it's 2x plus 1. You get the same thing. So, in this part right here, you could divide both or multiply both sides by negative 1. I'll just distribute the negative, because that's more similar to what we're going to do today. So here, again, we're going to add 1, and we get 8. And then when we divide by negative 2, we get negative 4. And keep in mind, if we just plug negative 7 in here, we would subtract 1 to make it negative 8, divide by 2, we get negative 4 the same exact way. So just showing it a different way, because this is more similar to what we're going to do today. The one on the bottom, right, if you need to find f of g of 1/2, first of all, we're going to find g of 1/2. So I'm going to say, okay, g of 1/2. And then I have to look at my piecewise and say, all right, 1/2, an x value of 1/2, which part does that fit into? In an x value of 1/2, 1/2 is something that's between negative 1 and infinity, so I only plug it into this one. I don't even worry about this part because it doesn't include a domain of 1/2. So this is going to be negative 1/2 minus 3, which is negative 1/2 minus 6/2, so negative 7/2. And then from there, I have my g of 1/2, so it's negative 7/2. So now I need to find f of negative 7/2. And I look at my thing here, negative 7/2 is a negative number, so it fits in with this domain here because it's negative infinity to 0. So I'm actually going to plug in this top one. This bottom one I do not deal with at all. So I'm going to find f of negative 7/2. I'm going to do 3 times negative 7/2 minus 4, which is going to be the same thing as negative 21/2 minus, is it, yeah, minus 8 halves. And at that point, negative 21 minus 8 is going to give me negative 29 halves. All right, so that's your warm-up. And now when we jump into this lesson, again, we're just going to worry about the absolute value part of this assignment. You know, and a typical question is going to be, take an absolute value. This is a much simpler one, but take it and then write it as a piecewise. So right there's our notation for piecewise. We would have to write this thing as two different parts, which all sum up to be one function in the end. But like we already know a lot about this graph, right? We know that the minus 2 is going to shift it right 2 so that the vertex will be like right there. We know that it's an absolute value, so it's like this V-shaped graph, you know, and it has a slope of 1 and negative 1 on both sides because it's it's 1x here. So we know what this looks like. We know the domain of it. We know the range of it. We know the 0 of it, positive 2. Right? We know a lot of stuff about this, but we don't know how to write this yet as a piecewise function. And maybe some of you could figure it out. It's not too difficult, but there are some steps involved with doing this, which I'm not a big fan of steps and making you guys just, regurgitate steps and stuff like this. But for this lesson, most kids, I think, find it somewhat helpful. Once you get used to it, it doesn't really feel like following steps, I guess. But step one is take your absolute value, the actual part of it, which in this case, the entire equation is the absolute value part. But keep in mind, we could add numbers out here and, then you're looking at the absolute value part only. But basically take that part and you need to create a case 1 and case 2 scenario just like we did for the warm-up, right? We had a case 1 and a case 2. So you kind of do the same thing when you're graphing it. So when we do this one, right, we're going to say a positive part is like the case 1 and then the negative part is like the case 2, right? So you're going to take x minus 2 and you're going to say, okay, x minus 2 is going to be greater than or equal to 0. And then we're going to say x minus 2 is going to be less than 0. And if you're wondering why do we use a greater than or equal to and then a less than, you'll see it when we write it. But basically, that point, right, where it's going to be equal to 2 exactly, you don't want to include it twice when you write it. So one of them is greater than or equal to, one of them is less than. Honestly, if you did less than or equal to and just greater than, it would be the same point anyways. It wouldn't make a difference in the long run. All right, so we've done that. So we have a positive case right here, and we have a negative case right here. Right? That's just setting up the domain for each line. That's all that part's doing. Now when you actually have to write out the equation for each domain, what you're going to do is, just like with the cases, you are going to look what the absolute value part is, and you're going to, for the positive one, you're just going to drop the bars. So in this case, if you just drop the bars, then you can almost put it in parentheses, but in this case, it doesn't matter. You're just going to get x minus 2, right? So if we just drop the bars, we're left with x minus 2. Now for the negative case, remember what we did in the warm-up, we made the entire thing negative, so that in the negative would be making the entire thing negative inside the bars, so then it's negative x minus 2. Again, just looking back at what we did, we put the negative in front of the whole thing, and then it's basically your negative case. And then step 3, you basically graph each part. So the negative, this is your negative line, that's a domain for it. This is your positive part, that's the domain for it. This is your negative line, that's the domain for it. And then you just have to write it. And then lastly, you would graph it. And you'll see that some of these graphs are not going to be perfect V-shapes. This one we're doing right here certainly is, but they don't have to be. So here we go. So just to do this one again, right? We have the absolute value of x minus 2. So what I'm going to do first is say, okay, the positive part, the domain would be if I just take what's inside the bars, x minus 2, and I say greater than or equal to 0, and I'll get x is greater than or equal to 2. Now the negative part would be if I said x minus 2 is less than 0, and I would just get x is less than 2. I didn't put in a negative sign yet. That's the second step. These are just creating domains for each line. Now when that's done, I actually now will just drop the bars and solve for each case. So the first one would just be if I drop the bars, I'm just left with x minus 2. Right? It's kind of a weird example. There's nothing else that you would do with that. It's done. Right? So the line, right, half of this graph is going to be x minus 2. And that's only going to be with a domain of x is greater than or equal to 2, right? That part goes to the positive, so I would say, okay, well, that's just going to be 2 to infinity, right? The other half of this line is going to be if I take, again, if I drop the bars but make the whole thing negative, I'll get that, which I'm just going to simplify to negative x plus 2. And that's the other line, negative x plus 2. And that domain, right, is this one right here, which is less than 2. So I'm going to say negative infinity to 2. Now, again, this is where the inequalities can be different, because if 2 is included on this piecewise, then it can't be included as part of this piecewise, right? You don't want to include it twice. 2 is only going to be part of 1. Now, it doesn't make any difference which one you put it on, because when you plug in 2, and this is like a check, when you plug in 2 into this equation, or this equation, you'll get the same thing. So 2 minus 2 is 0, negative 2 plus 2 is 0. That's a check. That's your vertex of the absolute value. So it's where both lines are actually going to meet, right? So when I plugged in 2, I got 0. So that's like a point. And then, you can just graph it from here. This is x minus 2, but only from 2 to infinity. So that's going to be going to the right, and it's a slope of positive 1. And this one right here is a slope of negative 1, negative x plus 2. So the y-intercept is 2, and the slope is, all you need to know is the slope is going to go up and to the left, and it's a slope of 1, or negative 1 technically. And that's it. And we knew that the graph was going to look like that, right? We already knew that from here, but basically what we did was we graphed it using the piecewise. So what we did was we wrote an absolute value as a piecewise, which in calculus is going to be very, very important when you have to find derivatives, because you can't find it from just an absolute value. So a very important lesson for what you're going to do in future years of math too. Just in case it seems trivial, like why would we even do this? Well, there you go. Okay, so here you go. I'm going to do another one with you guys, and this one has something on the outside of the absolute values, which is certainly more like what you are going to see. So just to give you another example, if you want to try this one on your own, and mute it and then just kind of check your answer with how it goes, I think that's not a bad idea. So we are going to do the positive part, and that's going to be if I just take the domain, right, or I'm just looking for the domain, I'm going to say, okay, 4x plus 2, and that's the only thing that's inside. I do not care about this when I'm doing the domains. I just take the inside of the bars, and I say greater than or equal to 0. I subtract 2, I divide by 4, and I get negative 1/2. And then for the negative part, 4x plus 2 is less than 0. And obviously, if this one's negative 1/2, then this one has to be negative 1/2. You're just going to get less than, right? Because an absolute value contains every domain. So this is everything if you put the two together. And then from there, right, again, for the positive part, I'm going to pretend like I dropped the bars. You can put parentheses, but it doesn't matter. And you'll get something like this part right here. You'll get 4x plus 2 and then the minus x. This is where you bring in this to solve for the part. So 4x minus x is 3x plus 2. And again, this is my, greater than or equal to negative 1/2 for the positive part. The negative part, again, if you drop the bars, but definitely use parentheses and then put a negative sign on the outside of it. So this is where you see this part. It's negative 4x plus 2, and then again you tack on the minus x when you're solving for the line. That's going to simplify to negative 4x minus x is negative 5x, and then it's minus 2 when you distribute the negative. And then the domain for the negative part was less than negative 1/2. Again, a great check. If you plug in negative 1/2 into both equations, you should get the exact same output, because that's the vertex of your parabola. So negative 3/2 plus 2 would be 0.5, right? And negative 5 times negative 1/2 is actually going to be positive 2.5. Minus 2 is another 0.5. So they meet in the same spot, 1/2. And that's basically the vertex. So you get negative 1/2, positive 1/2. And, the slope going to the right, it's going to be 3x. Or you can use the y-intercept, since that's included in this one, and just say, okay, well, I know that that's 2. And then all you need to do for a line is going to be connect 2 points. And then the one off to the left, is even steeper, the slope is going to be -5. So that means up 5 and left 1 if you want to do it that way. So from here up 1, 2, 3, 4, 5, and then left 1. And then you could certainly, well, that was not very good. But you can certainly connect those lines as well. Sorry, I'm trying to draw with a trackpad. But you kind of get the point. This is not a perfect V. This one's even steeper than this one. It's hard to tell, but it is. So this is where you don't have to get, you might not get a perfect V shape, and that's caused by this minus X on the outside. All right. All right, so the next, I think I have a couple processing partners for you guys. You don't have to do it in processing partners. You can do this because you're all watching this on your own. But just check in with the answers with this one. So I'm going to do this one out, and then you guys can kind of either tune in or tune out and just check your answers. So this one just says to write it, so we don't have to graph it. But you certainly could check it by graphing. And that's actually what I think we'll do on the end. So we have absolute value of 3x minus 1 plus x. So the positive would be if I just take what's inside, and greater than or equal to 0, and I get x is greater than or equal to -1/3. And for the negative, I'm going to get the same thing, but x is less than -1/3. Now again, with the positive part, I just drop the bars and go. So it's going to be 3x minus 1, and then plus x. And if I added that all up, I'm going to get 4x minus 1. Right? So I can fill that part in since I know it. It's going to be 4x minus 1. And that is going to be from, we're going to use interval notation. So we're going to say, oh, by the way, I screwed this up. Sorry. This is not -1/3. That is definitely +1/3. Sorry. Might have already caught that. So that's just going to be from +1/3 to infinity. And the other part is the negative part. So I'm going to drop the bars and then throw a negative in front of it. So 3x minus 1 plus x. So that's going to be -3x plus 1 plus x, which is going to give me -2x plus 1. And that's going to be from negative infinity to +1/3. But I don't include the 1/3 there since I included it here. And again, if I did do -1/3, I can check it very easily. Again, if I plug in +1/3 into this one, I get 4/3 minus 1. So it actually ends up being 1/3, which is totally coincidence. And then if I plugged in 1/3 into this one, I get -2/3 plus 1, which again is +1/3. So they each give me the same output, which tells me that's where the vertex is. It's a good way to check to make sure that you did it right. If I did -1/3, they would not have equaled the same thing, and then we would have had a problem. Another multiple choice here. If you wanted to do this one, you certainly could. You could do the whole thing out, but honestly, right, if you just look at what's inside, it's x plus 2. So your two domains, the positive is going to be greater than or equal to -2, and then the -1 would be x is less than -2. So I can already rule out B, because they see this one's greater than 1, and D, these ones are both wrong. So it's either C or A. So if you just did the positive part, right, if you just dropped the bars and simplified it, you'd get 2x plus 4 plus 1, which would be 2x plus 5. So the positive one is 2x plus 5 and greater than -2. That looks like this one's A. This one is not it, so A would do it. Just a little bit of process of elimination there. All right. All right, I think I have two more problems. Again, I want you to do these on your own, but you can certainly check in along the way. Make sure you're doing this right. This one's tricky. I think this one might be as tricky as it gets, but it follows all of the exact same rules. So what we'll do is, again, if you want to turn the volume down and go on your own, you totally can, or otherwise I'll kind of explain it as we go. All right, so we have y plus 4 minus x. Okay. We don't have y by itself, but that's not a problem. We can certainly subtract 4 and add x, and I'm just going to do that. So I'm just going to look at this as y equals 2, absolute value of 6 minus x. Interesting that x comes second. And then plus the x, and then subtracting the 4 off, right? So that's okay. We can just work with that one. So the positive is if I do 6 minus x, because that's what's inside the bars, greater than or equal to 0. This is where it gets a little interesting. You can subtract 6 and then divide by -1. Just remember, if you divide by -1, you do flip the sign. Or what I'm simply going to do is just add x. And I'm just going to get 6 is greater than or equal to x. And just, I want to read x first. So if I read x first, that's x is less than or equal to 6. Which is interesting. The positive case is actually a less than sign. That can happen, which is what happens when you have something minus x instead of x minus something, which is okay, right? That's totally okay. Now the -1 in that case would just be is x is greater than 6, right? And you could do it all out, but basically if I know this one's less than or equal to 6, this one's got to be bigger than 6. Now when I look at simplifying here to get lines, I am going to take 2, right? So I get 2 and then 6 minus x plus x minus 4. This is the positive. So I'm going to get 12 minus 2x plus x minus 4. And that's going to simplify to negative x plus 8, right? So I know half of it. So I'm going to have f of x equals negative x plus 8. And that's going to be from negative infinity to positive 6. That's the positive domain, right? The other one's going to be if I stuck a negative in front of it. So it's going to be 2 times now negative and then my 6 minus x plus x minus 4. And I can distribute, I mean, the 2 and the negative, like they're essentially going to be multiplied together. So I'm just going to distribute -2. You can do it all at once. You'll be okay. So it's going to give me -12 and then plus 2x and then plus x minus 4. So this is going to give me over here 3x minus 16. And there's your other line. So 3x minus 16. And that's going to be from 6 to infinity, the negative part of the domain, right? So again, I can check it. If I plug in 6 into both of them, I'll get -6 plus 8, which is 2. And if I plug in 6 over here, I get 18 minus 16, which is also 2. So great, right? That's my vertex 6, 2. So on a graph 1, 2, 3, 4, 5, 6, up 2. Super. And then as I go to the right, it's actually a positive slope of 3, right? The domain is 6 to infinity, so that's the one that's going to the right of 6. So I'm going to use a slope of 3, and then I can connect those. And then over here, to the left, I have a slope of -1, so that's left 1, up 1, and that's all that I would really need. Notice how if I continued this line, I'd hit at 8, which is good because that's the y-intercept. You could just use that. Again, we have something that's not a perfect v, but it does work. We can certainly check it on the graphing calculator. So I'm just going to check it. You don't have to do this, right? But I'm just going to show what was the equation. So I have 2 absolute value. So 2. If you weren't sure, absolute value is a math, and then you can go to the numbers. And then the first one is ABS, that's absolute value. And then 6 minus x. And then on the outside, I added an x and I subtracted a 4. So plus x minus 4. And then if I just hit, zoom 6, I'll get it on my graph. And there we go. There's our slope of -1. There's our vertex of 6, 2. And there's our slope of positive 3, right? So we do get this weird looking backward Verizon sign thing. But that's what our graph is. All right, last one. Again, I really want you to try this one on your own. I'm just going to give you the answer for this one so you can check it when you are done. All right. All right, if you guys did this one correctly, you should have gotten negative 3x plus 6 and just 9x, which is interesting. But the negative 3x plus 6 was from 1/2 inclusive to infinity, which means this one down here is negative infinity to 1/2. The key is here, you're going to have to use parentheses and then multiply the whole thing by 3 to get rid of this 3. And then you can just kind of work with it within the parentheses, and then the last step would be distributing the 3. You certainly don't have to distribute the 3 first because you can do what's inside the parentheses. And you guys can graph this, but you notice that 1/2 gives you 4.5 here, and 1/2 will give you 4.5 there, right? So 1/2, 4.5 is the vertex. And then again, as I go to the right, it's a slope of negative 3, so 1, 2, 3. And that would be that line. And then as I go to the left, right, because that's negative infinity to 1/2, it's a slope of positive 9, which is very, very steep. So I'm actually going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then left 1. Or you could just basically, the y-intercept is 0, so all you would actually need to go to is 0, 0. But that's on the way to this point here, so either one's okay. All right, and that's the lesson. So if you guys want, you can start the homework after. The homework's interesting. I want you guys to have fun with this. But you're going to create a picture with piecewise, one of which has to be an absolute value function involved with it. And then you have to write it out as 2 lines. So just put your work on the back for this. So you can do as many functions as you want to, but create a picture, right? And I've seen some good ones. And then make sure the picture from the piecewise is outlined in black or something obvious. But then if you want to add pictures around it, that's totally fine. Just make it sure that that's not, it's clearly obvious if that's not part of the piecewise, right? So just, I've seen some people do like, if you wanted to do like a shark or something, you could do the bottom half of the shark or something like that. And then you can add water, you can add fish, you can add whatever you want around it. But have fun with it, be creative. I kind of want it to be flexible. And then on the back, I just want you to find these values of it. So try and pick functions that have these domain values so that you don't just keep getting, no answer, undefined or something like that. Okay? All right, guys.